In this problem video, we're going to get practice using molarity in order to convert between things with some balanced chemical reactions. Now, it asks us in the problem, how many grams of copper, there's my endpoint, are required to react with 1.5 liters of 0.10 molar, and notice it reminds us that that means it's moles per liter, of the silver nitrate solution in order to form silver metal. And we're given a balanced chemical equation right here. Now, if you've already talked about reduction and oxidation reactions, redox reactions, when we pause the video in a moment, also try to assign and identify which ones are going to be reduced and oxidized in your reducing agents and oxidizing agents. Go ahead and pause the video and try to solve for the grams of copper required now. Okay, let's take a look. Now, this has 2 units inside of it. Remember, moles per liter, which means it's going to make a great conversion factor. This only has 1 unit in it, and it's almost certainly going to be the beginning of our problem as a result. So let's write that down right here at the beginning. 1.5 liters of silver nitrate. Now, we're currently in a volume unit. I want to get into moles because I can use my balanced chemical equation once I'm in moles. So to get to moles from liters, I'm going to want to use my molarity that I have up here. Now, that's 0.10 mole per 1 liter. So 0.10 moles in 1 liter. I'm also going to go ahead and put my species here because whenever we're doing things with a balanced chemical equation, it just tends to work better if we keep our species listed because we can cross-cancel that as we go too. So I can cross-cancel liters, I can cross-cancel silver nitrate. I currently am in moles of silver nitrate. Next up, I need to convert from silver nitrate into copper. And for that I can use my conversion factor that I can build with my stoichiometry. So I have AgNO3 on the bottom so that it'll cross-cancel. And then on the top, let's get moles on there as well. On the top, we'll have moles of copper. We come up here, I have 1 mole of copper for every 2 moles of silver nitrate. Moles of silver nitrate cross-cancel. I'm currently in moles of copper. Let's check to see if we're at our endpoint yet. We're pretty close. We want to get to grams of copper, and right now we're in moles. So I need to convert from moles into grams of copper. And of course, as soon as we see grams per mole, even if we don't think we have the conversion factor handy, we certainly do if we have the periodic table around. So let's go take a look at our periodic table. Okay, and we see here that our molar mass is 63.546 grams per 1 mole. Now I'm ready to grab the calculator. So we have 1.5 times 0.1 divided by 1 times 1 divided by 2 times 63.546, and that gives us 4.76595. 4.76595 grams of copper. Before we make this our final answer, we check our sig figs. Sure enough, we have 2 sig figs and 2. We never reduce it down further than that because this, and this, and this are all exact numbers. So 2 sig figs for my final answer. I'll chop it off right there. I'll have 4.8 grams of copper as my final answer.